Okay, seems I'm live. Let's see here. Alright. It is time now to get the next layer of the CAN interface working. And for that I'm going to be using CAN Open. Now it's kind of not real CAN Open. It's designed based on a lot of open information. Like there is a lot of data sheets that for motor drives that mention CAN Open and exactly like what variables they use. And I used a lot of that information to kind of create my own interpretation of CAN Open. And I think it's a little bit unfortunate that CAN Open is actually not open. It's a standard that in order to get the specifications you actually need to be a member of CAN Open, and that's kind of weird to me. Why would you then call it CAN Open if it's not actually open? But luckily there is enough information out there to kind of implement the basic functionality of CAN Open. And I think the most useful stuff, like the most useful functionality in CAN Open is the way that it's designed to be very flexible. So you basically implement a simple layer on top of CAN, which allows you to address variables on the different devices connected to the CAN network. And through the automatic synchronization, you can easily configure the network to update values automatically. So kind of like the devices don't really need to know about each other, as long as the CAN master knows which devices are connected. And the CAN master can then configure the devices so that, for example, if I have a control panel which reads like joysticks and buttons, I could configure that panel over CAN Open to broadcast the values of those buttons and potentiometers, and then I could configure another device to receive those values and feed them into whatever like control loop that runs on that device. And all of this type of configuration happens automatically through the implementation of CAN Open. And that makes it very attractive for what I'm doing here, because I want to connect, I want to have one board driving the motors, another one in the control panel, and then later I can simplify the design, but for now I use the same hardware for both the motor drive and the control panel. And they're going to be communicating over CAN, and I want to easily be able to like configure which values I want from any other device connected on the CAN bus, and I could also have sensors and like limit sensors connected to the CAN bus, and through CAN Open I can easily do that. The way that I've implemented CAN Open is I have basically two classes. One is responsible for the CAN Open protocol part, and the other one is responsible for managing all the variables. What I want to do, what I want to have, like the functionality that I want to have in such a solution, is being able to register variables from device drivers, which become available over CAN Open through the CAN Open addressing, and I want to do it as seamlessly as possible, so that I can be notified when some other device modifies my value, or I can be notified when some other device broadcasts a PDO, process data object, and the CAN Open layer on my device interprets that and automatically writes that to a variable. But it cannot be a solution where I just provide pointers to variables in different device drivers, because writing pointers directly is it doesn't really, like, it doesn't work when I have device drivers which can be running in different time domains, because everything is threaded. So I need to be notified through a function call that some data is ready to be written, and so that I can then lock whatever variable that I'm going to be modifying, and thus make sure also that there is no concurrent writes to the same variable by multiple subsystems. So let's have a look at the vardir implementation and also the CAN Open implementation. And I decided to move the vardir implementation into device tree because I want to be able to reference it from the device tree, so that I can, for example, have a driver that let's see here. So I'm gonna create a dummy object here for my CanOpen. Let's see. So CanOpen is also going to be a driver. CanOpen can also have a label CanOpen, and then it's going to have a vardir as the main variable directory. So anything that then wants to register parameters in this directory can just get a reference to the directory like this through the device tree. And vardir is going to be here. The nice thing about device tree is that I can configure even how much memory I reserve for different things, and that becomes kind of settings that are specific for a board. I could probably even generate the code, but although I wouldn't want to do that. I think keeping things such that the device tree gets compiled and then embedded in the firmware is much better than having some kind of script like a JSON file or whatever from which you then generate code, because it kind of becomes like every time there is some kind of automatic code generation, it tends to get messy, and it tends to produce bugs that are hard to track. So I want to have as little as possible of automatically generated code. And besides, compiled device tree doesn't take that much memory, and I can have it in the flash as well. Right now I have it in the RAM because I load it into the RAM because I was thinking that I could maybe use the device tree as some kind of runtime configuration directory, but yeah, I dropped that idea because I think that there are more lightweight solutions for that. So probably I'm going to be moving the device tree to flash completely so that I don't use any RAM for it. Anyway, so I have the variable directory, and this will be handled by the CanOpen driver. Let's see. Yeah, why do I have CanOpen as a separate library? I should just move it to the lib driver, because now it's a driver, so now it can live in the lib driver. Let's see. And vardir will go up at the top because I want to initialize it first so that I can use it in different devices. Okay. So the way it's going to work is that vardir is going to expose abstract interface, allowing other parts of the system to register global variables, or like global or local to this particular directory. So anything that registers with the same directory will have all the variables in the same place. And the nice thing about that is that I could also supply this reference to the variable directory to the console, and then the console can implement commands for modifying the variables. For example, you could have like set and then specify the name of the variable and a value, and all of that is kind of going to be working very seamlessly because the same code will run also when the variable is changed from CanOpen interface or any other type of interface that may be responsible for changing some exported value. So let's see here. CanOpen there, and now I'm going to go to the lib. Let's see, lib firmware. And I have the vardir implementation here right now, but this is going to go to lib driver. So the way vardir works right now is that it's just basically it's basically a little bit of code that kind of handles this dynamic registration of variables, and they can have different types like ints, floats, and strings as well. So I'm going to move this to, let's see, I'm going to move this to libdriver instead. And this is going to go into data drivers. Should I call it data? What should I call it? Probably I should be arranging the drivers by subsystems. So instead of just having arbitrary directories, I should be using subsystem names. Let's see. Driver. Let's move it just to the driver first. No? Node not renamed. Why? Why is it not renamed? Okay, maybe I can just do like this. It's not that much of code, it's just a little bit of code. Let's see where, there. So, what would be a good subsystem for a variable directory? Open, but I need to include device driver. Yeah. And because this is going to be a shared object, I don't want to expose any headers besides the abstract interface. Just to make sure that any kind of any calls to the implementation of this object have to go through the public interface, and then I can ensure that there is no concurrency issues when different parts of the different drivers call this code. So let's see. This would be device driver. Vardir, code, and vardir load. Standard declaration of a device driver, and then we have static int vardir probe fdt, and then it also gets the ID of the device tree node, which is being probed when the loader encounters a device tree node that has the compatible string equals to the name of this driver. Return 0 there, and then I'll have static int vardir remove. This will never be called on the embedded target. So this will just return -1 for now. And then I have vardir init somewhere, which is actually very simple. I'm just thinking, is this really a good idea to make this a driver? Maybe I should just keep... Maybe I should keep this as a library object and then create a driver that will manage an instance of a vardir and make it available to different drivers, to the other drivers. So I'm going to need to use this in the console and in CanOpen, at least for now. And the only way to pass references to other drivers in my system is to define that reference in a device tree, and then to use a public abstract interface to communicate with that object. So I do need to have a device driver that manages a variable directory. I'm just thinking of whether I should have the code for the actual implementation of the variable directory as part of the device driver, or have it outside of the device driver. I think it kind of makes sense to have it outside, actually. So I'm going to keep this vardir there, and I'll just add a driver. Let's see. So this will just expose a fairly limited interface through which device drivers can register their variables into this shared directory. Let's see. This is probably not the best candidate for being a device driver. Because I do need to, if I'm going to implement it this way, then I need to have a subsystem that manages all of the objects of the same class. And objects are separated by class. So two objects that have to go into different classes are basically two objects that have different abstract interfaces. So as long as some object can have a certain, can implement a certain abstract interface, that object automatically becomes a member of that class. So you can register a driver to export several different interfaces. It can be a serial port, it can be a PWM device, it can be an analog device, and then other drivers can easily just use the abstract interface to communicate with your device, as though without caring what is the underlying implementation of that the device, the driver that actually controls the device. So if I'm gonna do this this way, then I have to add a new file here, which is gonna be, let's see, which is already here, but just but it exposes just the direct function calls to the variable directory, and I don't want to have it like this. I want to have the main object hidden behind the public interface. Let's see. And I can't have a semicolon there because I have pedantic warning flags enabled. So if I put a semicolon there, the macro actually will define a few functions, and the last character would be one of these curly brackets. And if I put a semicolon after that, then the compiler will actually complain about that. That a semicolon is not allowed. It's not allowed to have semicolons after functions. Only after variable definitions. But of course that's just a warning, but because I have all warnings considered as errors, I don't want to have any warnings at all during compilation. Okay. Let's have a look at our way up here. So we need to have we need to type def this. I'm just gonna copy this so I can't be bothered. Vardir device, maybe vardir.c device, better. And vardir device ops. And then this will, the interface through which we're going to communicate with the vardir is going to be, it just needs to contain a few functions, because all of these functions are basically like utility functions that just convert from the specific type to a generic type. And each vardir item is basically an int32, and it can contain 4 bytes of whatever data you want to put into it. It can be a pointer to a string, for example. I'm going to check what would be a good candidate here for. Let's see. So even things like this, for finding entries, they should be static, because I don't want to expose them to other drivers. It shouldn't be possible to manipulate an instance of vardir entry from outside of the variable directory. So it shouldn't be possible to get a pointer to it either. But I have to think a little bit about how I'm going to implement this. So I have several methods. I have set float and set int. Um, and And then also there are variables that are directly stored in the variable directory, which can be modified directly. Like you just call vardir get int or get float or whatever, and then you specify the name of the variable. But there's also variables that are that can be stored somewhere else. In which case I call it a real-time variable, which is implemented through two function pointers, which are defined in the ops object here. And there is a write and there is a read. And this allows defining specific methods that can retrieve a value, which is then accessible in a generic way through the variable directory. So I could rewrite this actually, so that only the method, only set int and set float. Let's see, vardir entry set int. Okay, anyway, I need to have something to, I need to have a method to register a new variable. Register is obviously a keyword, so we'll call it add. And that would take vardir device. Yeah, so basically here, there is so the field is the field is just a variable that is directly stored in the directory. Entry is a variable that uses the callbacks to set and get the value, and string is just sort of a variation of the field. So I could actually use the same prototype for the interface function, or a similar prototype. Let's see. and instead of vardir is going to get the handle to the device. And then the ID of the variable. So because I wrote this code for CanOpen, I used the ID as this is going to be equal to sort of the CanOpen ID, and in many ways the way the interaction with a variable directory is very similar to how you would interact with a CanOpen directory. The only difference is that it's also possible to register names for variables, so that it's possible to set them from the console, setting them by name, which is also useful for manually just modifying the values. Let's see. And then there is type and the default value. This could be static and there could be dynamic. And the dynamic one will take 2 function pointers. Right, and then there is also it's also necessary to make sure that the function point, the callbacks that get called by the variable directory, they need to be able to take an argument that can somehow identify the object that owns them. So they need to see. And the way I've been doing it before is just by providing the vardir entry ops, and the vardir entry ops then becomes a member of the object that then registers with the variable directory. So whenever set or get is called, it will also get a pointer to this vardir ops, and then the callback can use the container of to get the reference to the actual local object, which is not even visible outside of that driver. Okay, Damien. So you simulated it in KiCad, nice. But I haven't been looking at it in detail. But are you using the voltage after the resistor splitter? Are you using that to drive the op-amp? Because that's something I thought that, well, that doesn't seem to be like a good idea. But maybe I'm wrong. Maybe you're doing it in some other way. Okay. And static and dynamic, and then probably some kind of prototype for set. Damn, I feel like this is getting messy. I feel like it's especially messy because, like, when I start wanting to support different width of integers and like signed, unsigned, float, string, value. Like, how can I express this as a generic single method that kind of can compress all of this mess into one method, like set and get. Okay, how about this? But the current you're going to be getting, like because you're putting resistors on the power path, the like any kind of current draw from by the op amps is going to lower the voltage. So it's kind of, yeah. I guess it would depend on how powerful load you're going to be driving. Okay, so get will accept an ID and a name, and if first it will search by ID, or if the name is null, then it will just use the ID to kind of find the variable. And then the output will be written to a 32-bit integer. And also this 32-bit integer will be always stored with most significant bits first. Let's see, is that how it's going to be stored in CanOpen? Anyway, I'm going to use whatever format is used in CanOpen, regardless of the format of the hardware. Could this really be a good implementation? I suppose I could just implement this helper functions then, so that it is possible to easily just get or set values of different length. Declare, of course. Define device class goes into the C file. This is pretty much like a very simple implementation of SysFS. Really. It's like, it does make sense to use Linux constructs when a system gets past a certain complexity level, and specifically like for systems that that are originally designed to manage files. Like for example, Linux and any kind of Unix is originally it was designed to manage files, so everything is a file because that's simply the concept that was most familiar to the system. But for an embedded system like this, there is no concept of files. So I think it's kind of like, it's not the right approach to try to re-implement the same type of abstraction like we have in Unix, where everything's a file, and then you just implement file ops, and you have like generic read-write calls that just take buffers, like raw buffers, because that just adds too much complexity. So that's why I went with this approach of using specific abstract interfaces, which directly implement certain functionality, but then you can have several devices that implement the same interface, and they can be used interchangeably in place of any other device that implements the same interface. And I think this approach is a little bit cleaner, and it doesn't, even though there is a little bit of code that needs to be written, it's still not as much code as, for example, in some system that uses file abstraction as the main abstraction for different device drivers. So these functions are going to be, let's see here, so they're just going to be here to guard the vardir data from concurrent accesses. Actually, I could just copy all of this. So instead of add field, it's going to be add entry. And then this will be ops. and the problem, so for example, one solution could be to just have a like get that get would just sort of get some pointer to this entry, but that's not going to work because then we're throwing this structure outside where multiple threads can access it concurrently. So that's not going to work. But is this really enough? So just having uint32. If everything is uint32, so this will have implications for like future implementation, because well the first use case for this variable directory is obviously the CanOpen interface, because it requires a variable directory. It gets really messy doing it in any other way. So the variable directory is absolute requirement for CanOpen. But I'm just thinking if I'm going to be using this in some other ways, whether it's really a good idea to keep it as uint32 there. I think I will do it like this. So this seems to be flexible enough. So now it can check sort of the type of the variable and then call the appropriate, sort of do the appropriate conversion before writing it to the address pointed to by value. And set will work in the same way. Except it's going to be const void value, because we have a read-only parameter. Yeah, this seems to be flexible enough. Check my implementation here. So there's vardir. Maybe I can just implement this methods directly. There's going to be a bit too many layers. Calling it like this. There can be a case which would be problematic, and that's if the callback that gets called when I do vardir set int, the callback that's defined by the implementation specific code. If that callback then calls back to the same variable directory and tries to do something, then I'm going to be waiting on a lock that's locked here. The question is if that limitation is okay to have. Just a good thing to keep in mind. I don't think I call back into the vardir anywhere, and there's no reason to do that either, because the get and set just accesses the local data in the driver, and it shouldn't be setting any other variables, so it doesn't really make sense. So if that one fails, then I do this. If name is not specified, then I just call the set int directly. Okay. Same as thought. I probably would need to do more refactoring this code. And I also have a version that takes the value as a string and then just converts it, which is useful for the console. And it actually could be implemented in a very flexible way, so that if the variable that's been registered, for example, is a uint8, and you call this set with like value var string, then the conversion can just be made from the string to uint8. or uint16 or uint32. It's only relevant to have the type when writing the actual value to the memory where it's stored, just to make sure that it's always stored as the type it's been defined as, and then conversions can be made from other types. I'm going to keep this string unimplemented for now. This will be set, and then we'll get here. Okay. Kind of want to get at least something running pretty quickly here. I won't spend too much time on this. I find it's usually better to get something running quickly and then improve it than to spend too much time on little details, unless it's important though. Like unless the details can cause a lot of problems. For example, before sending off something to manufacturer. But yeah, before actually making a release, then I would probably go over every single function and review it, just like I did with components and labels on the PCB. I'm kind of thinking about some good way of doing that. And what I really want to have is a utility that works kind of like obj dump, which dumps the symbols, their size, and their checksum. And then I want to be able to mark certain symbols as reviewed, and then the checksum will determine, like if the checksum changes, then that symbol automatically gets reverted to unreviewed. And and then I can have a git hook that will automatically run when making a release, for example, of the software, and it won't work unless the software has been completely reviewed. So that will be a good way to make sure that all the code is reviewed before it actually ends up in a release. Oops. Oh, okay. Is that vardir device or driver? Right, vardir driver. It's supposed to be driver. Oh, of course. And this has to be driver as well. Yeah, this needs to accept pointer to pointer Parameter name omitted. So now the issue is that these functions are going to be searching, like looking up the value again, which is going to be slow. Do it twice. Completely unnecessary to do it twice. But I'll just fix the code for now. I'll just make sure that it compiles, and then I'm going to do a simple test that will allow me to set a variable from console, and then I'm done for this video. Passing argument form. So I think it will actually make sense to move all of the functionality of variable directory directly into the driver. Instead of adding a bunch of methods that just have different suffixes. Damn it, I used the vardir instead of dir everywhere. Get becomes void, and set becomes const. Name, oh, type, of course. The type also needs to be specified. to advise it. Missing return value. I just need to, and I also need to make sure that I unlock this. And return 0. Okay. This driver to the compilation included in the firmware. And I could change something like this. Something that would actually be useful. Like obviously I could use the, let's see here. I could like make this LED blink with a different interval, but that's not very useful. Let's see. I could actually start implementing the functionality to switch between modes. So I'm going to use the CAN address switch to switch between master and slave mode. The switch is located here on the schematic. So I connected a little dip switch to an SPI GPIO expander, and setting one of these switches will toggle the board between being a CAN open master and CAN open slave, and maybe I will use the other three to specify the address of the. Or actually, it doesn't really matter in this case, because we could say that master is always address 0. So unless the address is set to 0, then we are running as a slave. And then if running in slave mode, then setting variables in the vardir will actually directly affect the motors. You can see I have two servos here. One is a cylinder linear actuator, and another one is like a geared servo. I could add something simple here actually, like version of this firmware. And I will also supply the vardir to console driver. Version. I'm just going to place a static variable here to test this functionality, and then I'm going to remove that later. Okay, and then in the console, where's the console? The console is actually here. Here I have a few methods to, let's see here, so set. Yeah, so I have set and get. I have cmd set and cmd get. And now I can actually simplify this a lot by instead of converting it directly, I could just send this to the vardir code. get is also, let's see. In fact, maybe even set and get can actually be, no, that's wrong. So I thought that maybe I could place those commands in the vardir driver, but because vardir is such a basic core component, it actually gets initialized before console, so I can't do that. Where's cmd get? No cmd get. Must have deleted it. And then for getting the value, I can do like this. Maybe I'll just use 0 as invalid ID. Or does that not make sense? It needs to be, so yeah, this is gonna be I'm actually gonna rename them to read and write, because they start to really resemble read and write, because I still need to supply the size of the buffer that I'm going to be reading into. I wonder if 8 is enough, unless it's a string. It's going to be, let's make this 16, just a small buffer. And if it's not, if it failed to read, then I should be actually returning the return value. Return the error that's returned. So now I've added the get and set to the console, and next, let's see. So here I supply the type of the argument that's being passed, and this would be I don't think I need the size though, not for set. I only need the size for reading out the values. And this is the type that I expect to read. So if it's a string, then the vardir code should just convert the values. Let's add this functionality. Entry to string, I could use that. Oh, I have a copy of it in loop can open as well. Close that, so just using this one. to make it a little bit more clear what these types mean. Oh, yeah, and this shouldn't be console, it should be, this should be the console device. Or, no, actually, it should be like this. Because this is private code to the console driver. I'll do it like that for now. Declaration of vardir right. Already have it here, but I think it can actually be the case that vardir is not specified, so set and get should check if vardir is specified. because I've added the device router to the compilation. I just want to rebuild everything. Let's see. In the device tree, do I have it there? Yes. Cool. I used con instead of self. Okay. Can't use this function here. This is just to make it easier to use these functions. The abstract interface functions. Static, dynamic. I'll just go with get and set instead of read and write. Get. ID, name, so order set definition. Oh, okay. So that was related to the previous error. 32. It's not supposed to be here in 32. ID name type well size. ID name type well size. Parameter 5. Oh, that's static. Okay. Name, type, and value. I suppose this should actually be a void pointer, const void, because this should be converted from the type specified here. Let's see. I want to get this done as quickly as possible right now, so I will just supply 0 there, and then let's see. Or maybe I'll just do like this. Let's see. Arguments. Oh, okay. Right. Yeah. That's what happens when you copy paste. I copy pasted all of these lines and I forgot to change the actual name of the call. Get string. Oh, okay, that's by ID. Use it like this. Oh, this is getting really messy. I really need to clean up the whole vardir code. Maybe like re-implement portions of it. So if this is equals 0, then ID becomes E ID. Okay, I'm gonna have to finish this because I have to take my dog out. Come in.